Hello everyone, this is Mike and welcome back to the channel. In today's video, we're going to be looking at the second episode in my Build a Script series where I take some admin task and generate a script for it from beginning to end. So with today, we're going to be looking at a topic that came up in a PowerShell class that I was teaching a couple weeks ago where the students wanted to have a script that they could use to point at one or more servers and search the non-operating system drives, so the data drives, to find files that were either overly large or files that have not been modified in a certain amount of time. So find big files or maybe find files that haven't been accessed in like 3 years or 5 years or something like that. So basically doing file audit searches on servers. So we're going to put together a script here that searches for files on remote computers based on date or size, accepts one or more computer names, accepts objects, computer objects from Active Directory because, why not? Works with pipeline input. That's how we'll put those computer objects in there and outputs objects back to the pipeline. So with this, I wanted this to be more of like kind of like a smaller script here where I'll take the output, make it objects back in the pipeline to then potentially write other scripts or other functions to do something with that. Maybe, make something that outputs CSV, make an HTML report script, something like that. So this script basically grabs the raw information and then we can write other maybe controller scripts to do something with that. So let's switch over to PowerShell here, switch over to the ISE, and kind of have a look at where we're starting at here. So this is the working command that we came up with to build the script around. And so when I mean by working command, what in essence would get the job done? So the requirements that we were given, or that I was given, I guess I should say, from my students, they had PowerShell remoting enabled on all their servers. They were not using any products that might have WMI open. So they weren't using Configuration Manager or anything like that, or any third-party monitoring products to use those protocols. So basically, like we had the ability to use WSMan as the protocol, so PowerShell remoting or SIM or things like that. So the second thing, since we could use remoting, the second thing was what would be the best way to get this information. Right. So there's a couple schools of thought here. So for instance, one of them, the thought was we could use PowerShell remoting, like invoke command, to do like a get child item. Right? Something like this. So get child item, you could give a path to it if I wanted to search the D drive and tell it to do a recurse and something like that. Right? So the problem that we kind of fleshed out with that is while this might be the faster approach, for, let's say, average size volumes, it didn't really filter for what we wanted right up front. So with get child item, I would then have to pipe it to select object, and then be able to, not select object, to filter it, pipe it to where object, where I could then filter by the date or the size or things like that. So I would be grabbing like all of the files, from whatever that volume is, and then having to pipe that to where object from there. So we decided instead to go with searching the WMI repository, which if you're not familiar with it, there's a area within your Windows operating system that's been around since the NT4 days. Some people might call it the WMI database, or you might call it the WMI repository. But basically, it's an area that Microsoft built to allow for namespaces, classes, and objects to manage a computer. Okay, so like you have information about all of your hardware there, your operating system, your apps, your hardware, your BIOS. And that is a fairly standardized thing that's been around since, again, the NT4 days. So Microsoft back then had created a protocol to access it, DCOM or WMI as the protocol. And roundabout when PowerShell version 2 came around, there was they're not really a rebuild, but a redoing of the protocols that access this information, and that's where the protocol WS-MAN comes from that PowerShell remoting uses. So the commandlets get sim instance also use that same WS-MAN protocol. So since that was available to me, in the WMI repository, there is an entry for every file that's on the drives of every computer. So it's sim underscore data file. So that class would have an object for each file. So it's not the actual data of the file, it's basically like the properties of the file, like the metadata. And you can query for that. So we used to use this a lot, or at least I used to use it a lot back in the day when I was doing Exchange administration, Microsoft Exchange, and I used to have to search like every computer in the environment trying to find PST files, for instance. So Outlook offline data files. So it came in very handy for that. So with this, I can feed it filters that can cut down on the result set that's brought back from the repository. So hopefully make it perform a little better. Right? So with this, we kind of came up with a drive that we wanted to filter. The modified, okay, so last modified would be some date that they could pick. So if I want, 2 days in the past or 100 days in the past or something like that, and a file size. So we could potentially filter off of that if we wanted to. All right. So this was the basis of what we had wanted to do. All right. And so for the setup here, I basically have on my server here, I have a D drive, which is the data drive, if you will. I've got a couple folders and I've got some small files and one that are reasonably new, 5 meg and a couple 10 meggers. And then in the other folder, I have a couple old Canon RAW files, which I happen to have laying around. I do photography on the side, so but these were shot in 2014, so these are really old files. And they are 25 meg and 27 meg respectively. All right. So that's what I'm going to be querying. So it's the data drive of this server that I have. All right. And that is the thing we want to focus on here. We're looking at data drives on these computers. So I'm not going to be querying a C drive at all. All right. So that's what we want to find here. All right. So so this is the working command that we're going to be starting with. Okay, and this is just one line of code. I know I got a backtick there, but if I get rid of the backtick, that's basically what PowerShell is seeing here. It's saying one big line of code. All right. So if you want to make it a little more readable, you can add a backtick and then do a carriage return. And then the backtick, if you will, is in essence escaping the carriage return. So that's the escape character for PowerShell. So uh, the 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 service, if you will, doesn't really see that carriage return. So this is treated as one command line, if you will. All right. So this is where we're going to be starting from as we build our script. All right. So to start with, I'm going to do the typical things that we're going to start with here. We're maybe identifying things that would make good parameters. So the computer name would probably be one candidate. I don't want to hard code a computer name, so that sounds like that would be a parameter. We're gonna query this. We're always going to query this class, so that's not going to change. The drive we query probably would. The date modified, the file size, those are the things that we're probably going to want to make parameters out of because those are the things that would have the potential to be changed. Okay, so one day I might want to find files that are, show me files that are bigger than 2 gig. Show me files that are older than 5 years. So whatever that criteria is, it might change as we go. So I'll start off with adding commandlet binding in, as I typically always do at the beginning, and a parameter block. So remember the commandlet binding allows for PowerShell to treat the script here as an advanced function. So it brings in support for things like error actions, verbose output, debug output, things along those lines. Right, and then in my parameter block, I'll go ahead and make the first parameter, which is going to be cast as a string, and I'll just call it to stay consistent. We'll call it computer name. Right, and trying to type it pretty so that it kind of tab completes ultimately the same way that other commandlets that use computer name kind of look. So that's where we, let's say, want to start. Right? So then we could just very simply, in the body of the script, we're running this command, and we could just kind of tack that in right there. So, computer name, something like that. Right? So then we could, if we wanted this to have multiple computer names sent to it, we could add the brackets right there. That would allow multiple values to be sent to a computer name when running our script here if we wanted to do that. And if we're sending multiple computer names, we should probably set up a for each construct. So we'll do for each, and then we got to give a variable name for each single computer. That could be in $computer name if there's multiple there. So I typically use $PC. It's kind of like how I normally do this. Computer name, and then we'll open a script block, and then close that script block. And then everything inside of here will run once for each computer, for each object that was in $computer name. Right? So if two computer names are in there, this code would loop twice. And then I'll kind of change this back to the variable that represents each single computer like so. Right? So that's going to be our very beginning here. And let me go ahead and save this. And let's see, that's something else I was working on. So data, and let's call this, I don't know, file demo 1. Right, so file demo 1. And let's go ahead and maybe try that. File demo 1, computer name, and the name of my computer here is DC1. And see if I get some type of output, which is cool. So it's matching up on those raw files because if I look at the filter that's hard-coded, it's last modified was less than this date, so it's showing everything older than 529, and the file size is greater than that many bytes. So if you're not familiar with that, that is how many bytes are in 5 megabytes is the value there. If you don't know how to get that, in PowerShell, PowerShell knows all these units. If you do 1 MB, that's how many bytes are in 1 megabyte. 1 KB, that's a kilobyte. 1 TB, that's a terabyte. So if I want 5 megabytes, 5 MB, there's how many bytes are in 5 megabytes, right? So, so that gets us at least rocking and rolling here. And let's maybe just check one more time. Run the script, and maybe I only have one VM running here at the moment, so let's just do 2 computers, and away we go. All right, so that gave us that output there. All right, so that gets us started in the journey here. So it is taking multiple computer names. All right. So now the next thing we're going to probably want to tackle here would be like these values here, because these are the hard-coded things that we might want to change each time the script was run. So it sounds like those would be good candidates for parameters. So maybe we'll make an age. Right, so how old are the files I'm looking for? So maybe I'll grab that as an integer, $age, and probably want a size. All right, so again, cast that as an integer and dollar size. I should probably capitalize $A for age there as well. And with this, you're probably not going to want to have to supply the sizes in bytes. Right, so I mean, I'll mess that up pretty much every time if you ask me to do it. So maybe I'll do MB or something like that. So the script I wrote for them that we did during the class, we used gigabytes. That's what they cared about. Anything less than a gig, they just didn't want to know about it. Right? So you can kind of pick what would work. For me, I'm working on a small VM here with not a lot of space, so megabytes are going to be what I'm caring about. But this could very easily be GB as well. Right? So that gets the start there. Right? Um, so now we're going to want to maybe think about this here. Okay. And so that would be the drive that would be queried. So remember, we don't want to query for the operating system drives. Okay, so we want strictly the data drives. And for this particular customer, they did not know ahead of time what drives that would be. So on one server, it might be a D drive. On another server, it might be an E drive. On another server, it might be a D drive and an E drive. So they didn't know up front. So that would be something that we would want the script to figure out. So that was one of the challenges that we had, was to basically, try and figure that out. And so with it, if we're doing this gets some instance, we do have the ability to potentially query for that. So if I do a get sim instance, and we look at the class Win32 logical disk, that will list all of the drives that are on a computer. Right? And again, I could point this at a remote computer, which is what I'd end up doing in the script, and get the drives. And the drive type is kind of the important thing here. So drive type 3, and you can go look up, if you Google for Win32 underscore logical disk. So if you do an internet search for that, get the Microsoft Docs page, and then go look at the properties, it'll tell you what the different drive types mean. So 3 is a local disk. 5 is a DVD. 4 is a removable disk. I think type 2 is a floppy. So basically what I want is I want drive types. I want drives that are drive type 3 and that are not C drive. Okay? And that should give me the data drives that I'm after. So those are the ones that I want to search. So we want to basically put that together, if you will. Okay? Um, so for each computer that we're going to do, we're going to go query for that. Right? So because again, you need to do this for each individual computer. So we could do a get sim instance, and in this case, the class name that we were looking for was Win32 logical disk. So then we're going to take the computer, which was $PC, and we're going to need a filter. All right, so we want, and the filter here, this is a WMI filter. Okay, so that is its own query language, and it uses different comparison operators from PowerShell, and it is cast basically as a string. So you're going to put the whole filter in a set of quotes. So typically use double quotes. And so we're going to look for, we want drive type equals 3. And literally the word and. Now in PowerShell, if this was a PowerShell comparison, it'd be dash AND. But here it's just the word and. And also you notice the equal, that's how it is there. Remember in PowerShell it's dash EQ if this was a PowerShell comparison, but it's not. It's WMI. And we want the device ID. Remember here, device ID, I want that to not be C drive. So drive type was 3, so we got that. And then device ID not equal to C colon, right, is what we're looking for. So device ID, the symbol for not equal is greater than or less than and greater than. And then C colon is what we want. And because this is considered string to this query, I have to put it in a set of single quotes to identify it from the outer double quotes of the whole filter. Right? So that should get that. Okay. Now, one of the things I don't like that happens with this script is it kind of scrolls off the screen a little bit. I mean, I guess I could just make the script kind of wider there, the ISE wider. But if you don't like that, you could again use some backticks, if you will. So one of the things that you might do is maybe make it easier to read all the parameters. You can kind of backtick and then line them up. So every time you have a start of a parameter, just kind of do that to then line them all up. So kind of keep in mind, I am putting the space there and then the backtick. So that way there's a space between where this ends and then the next parameter begins, because PowerShell again doesn't see the carriage return there. So that could be a nice way of maybe organizing all of the parameters that you're calling on a commandlet when it's like, like a long line of code. There's also splatting you could do where you arrange the parameters in a hash table and then call the hash table to the command. So we're not going to get into that here. We'll do splatting in another build a script series a little down the road. All right, but this is one way that you could make it look nice, at least when you're putting the script together. All right. And one final thing, I should probably store this in a variable because there might be, well, we're going to need to work with whatever value that is. So since this could be one or more, I'll kind of call it $drives. And then let me now reline all these up. I'm kind of a stickler for proper formatting, makes it easy to read. So we're storing this in that variable, and one or more data drives could come back from that. All right. So then what we're going to do, since we know that there might be one or more drives in there, that's now another for each. So we're going to need to loop through each drive that comes back. So we'll throw another for each here, and this will be $drive in $drives. And then we'll have our script block for that. And let's see, let's carriage turn this down, close that there. And maybe tab that one in a little bit. There we go. All right, and then all this stuff will get tabbed in. All right, so basically the second for each, this will be code that runs for each drive that was in $drives, the array there. All right, and then now we can start with, let's say, something like this. All right, so the way that I'm probably going to want to put this together here is we're going to build the filter and then kind of add it onto the command. Okay, so maybe something like this. So let's get rid of that and imagine right here. We'll do something like dash filter, and then we'll feed it some filter that's in a variable that we haven't created yet. All right. So ultimately, that's what I want this to look like. All right. So we need to build that up. So because my thought here is when we're looking at what we're going to want to do, we're always going to want to filter for drive. Right? So we're going to need that regardless. So that's always going to be there. And then we might be filtering by age, we might be filtering by size, we might be filtering by both. Right? So those are so we're going to build this filter up in pieces. So the first one here, we'll kind of define the filter right at the beginning here. And we'll say drive equals, and then I basically need this part, okay, which is the device ID. So that is in string. Okay, so if I took kind of the output from this and piped it to get member, um, so device ID, that is string, and it literally is those two characters, C colon or D colon or whatever. So those two characters, that's what I'm after. So I don't need the whole object here. I just need this part, which is the data out of the device ID property. Right? So that's what I need to kind of put here. So drive equals, and then since it's a part of the variable, I need to use a sub expression. So if I just did $drive.device ID, that would not work right. So that would dump whatever was in $drive Like you would read this first, dump the whole object from $drive, and then see this as just another piece of text. It doesn't associate this and this together. So I need to make a sub-expression out of it to make that happen. So I do a $sign, open parenthesis, and then close parenthesis behind it. And then that now tells PowerShell that, hey, this is a piece, right? So these two belong together. Right? And because this is inside of something that's ultimately going to be a WMI filter, and that is text, I need to put it in a set of single quotes. The whole thing, like so. Right? So that now establishes the first filter that we could use, and then we're feeding that here. Right? So we should probably save this and see if that piece is working. Right? Kind of build from scratch here and then see if each piece works. Kind of helps from the typo perspective. So let's just query one computer, and it looks like it's grabbing some stuff. All right. So if you notice here, it's grabbing, things that are, the recycle bin, my file 1, file 2, file 3, and then my Canon raw files here, and a system volume file, and that's what's on that volume. So it's not a lot, but at least it's seeing the D drive. So that's what it brought back. So that filter's now into play. So now what I want to do is I want to build off of that filter if this parameter was called or if this parameter was called. Okay, and we do that using an automatic variable that PowerShell has called PS bound parameters. I'll type it out in a sec here, but let me kind of describe what it does. So in PS bound parameters, this is basically a hash table of all of the called parameters when you're running a commandlet, a function, or a script. Okay, so if I ran the script with the age parameter, there would be an entry for that in this PS bound parameters hash table. So there would be the name of the parameters, in this case it'd be age, and then whatever the value was supplied. Okay, so we don't need to worry about the value because that will be in this variable. But to know if that has been used, that's where this can come in handy. So that's a great use of an if construct. So if you do an if, and we'll do $PS bound parameters, we'll call the contains key method, contains key method. And in this case, the key would be whatever the name of the variable is. So let's say it's age, something like that. And then outside that if, and then what do we want to have happen? So that's the code in the script block. And what I'll do is I'll take the filter, dollar filter, and I'll do a plus equal to append to it. Okay, so if there was a number in there, that would be a math operation, but dollar filter has a string in it, so doing a plus equal will append onto that string. And then we want to put a space, because that's where adding onto that filter, and we'll do and a last modified, which is, oops, I can type, last modified, and then we want that to be less than whatever the date was here. So, and I didn't define that yet. So let's do, let's just make up one. So it'll be $date. And we'll, let's see, that's closed off. All right, cool. So, all right, so we need to, so that'll kind of tack this piece onto the filter that we're building, which thus far currently just has this part in it. So it's like drive equals D colon. Okay, and then we're going to have the and, last modified, less than whatever the date is. Now I haven't defined this variable yet, so let's go ahead and do that. All right, so I'd want to do that somewhere here. It doesn't have to be in the for each because I'm just going to do it once. So maybe we'll put that up top here. And let's see. So we're going to need to, let's say $date equals, and then we'll grab, because what I want the age to, if they put like 100, I want it to be 100 days in the past from when the script was ran. So I could do that by grabbing the date. So I could do get date and then call the add days method, and then put it in the past by doing a minus and then whatever the variable was, whatever the number was in the variable, like so. All right, so that would grab from the current date, it would subtract whatever the number was there as days. So if someone did 100, it would grab the date from 100 days ago. So that's what that would feed. And then that would feed into here as a string object. That will work. All right. So we could feed that in there. And so if somebody used age, that would go ahead and grab that. All right. So so that should work. And let's go ahead and make sure it works. So let's do age was our parameter, and maybe I'll say, show me things that are 3 days and older. And notice that cut the result set by a few here. So these are my raw files from year 2014 or something like that. So it's showing me files that are 3 days old or older. Right, that's where the cutoff line is. Anything older than 3 days is what's happening here. And the 3 days is based on like right now when the script is running. For me, it's 5/31 year 2022. So the Tuesday after Memorial Day for you folks here in the United States. All right, so that's 3 days in the past. So that's working there. All right, if I did 1 day, I get more results. Okay, so these files were all made. They're newer. They're obviously not from 2014. I think they were made a few days ago when I was setting up the demo for this video here. All right, so that's getting that done. All right, now the other thing I need is we need another filter here, and we're going to work on size. Right, so we're going to take this, and just to save on typing there, I'm just going to dupe it right there, and we're seeing if size MB is called. And then we'll add to the filter. In this case, size, when you look at the WMI data, the property is called file size. All right. So again, if you're not sure, because it doesn't really show up here, what I could do is, again, make sure you're getting a small amount of output before you do this. And then pipe it over to maybe, let's do select object. Let's grab the first result and then display all the properties by doing property star. And then that can let you see potentially what you're working with for properties. So notice there's file size right there. And last modified, that was the filter we just built a few moments ago. All right? So that's what I'm going with here. So you can't always trust the output that shows up on the screen by default. That's doing, in essence, default output. So PowerShell has a whole bunch of different views defined for if there's a certain object in the pipeline and it has to be written to the screen, how does it show it? So this one is showing, these properties as a list. But if you want to see all of them, property star is a good way to do it. And then you can examine all the properties that are there and their values. All right? And if you wanted to see what type of object was there, you could further pipe it over to get member, and you could see the property and what type of object it is. So last modified is a date time object. File size is a 64-bit integer. File name is a string. So encrypted is a Boolean object. That means it's either true or false. Okay, so you can pick up all that information from there. Okay, so in my case, file size was the property, and let's see, what do I want to do? So remember, it's in bytes, so I'm going to create a variable here called $size, which we have not defined yet. And then up in the beginning here, we're going to kind of take that and work with that. All right, so actually, in fact, we don't have to do it in the beginning. Now that I say that, so this if could definitely be multiple lines of code if we wanted to put it on multiple lines. So in fact, let's go ahead and do that. just to make it look a little different here. Okay, so the filter will be the second line, and then the first line would be let's define what dollar size is going to be. So dollar size equals dollar size MB times whatever the unit is. So in this case, it would be 1 megabyte. Right? So this would take a size that was in megabytes and multiply it by however many bits were in 1 megabyte, and that would convert it over to bytes. Right? If you had bytes and want to convert it to megabytes, you would divide one by the other instead. Right? So so that should cover that math. Size MB times 1 MB. So that's 1 megabyte. And remember, PowerShell knows that, right? So if I do 1 MB, it knows how many bytes that is. So in essence, by doing that, we're basically saying, hey, take whatever was supplied in this variable and multiply it by this many bytes, right? That's what it's doing. So that'll convert it over to bytes, which is the unit that's stored, right? So that, and then that would tack this part onto the filter. So that should work fine there, right? So go ahead and do a save on that. And if I kick in the script off again, so we got a size. Oh, let's take the size back down to, actually, let's take the age down to nothing. And then let's do size. Size MB, let me see things over 6 megabytes. So that covers that. And what did I do? That's showing the wrong data. Hold on. That's showing things that are smaller, because this is smaller. This is smaller. I think I just got my, oh yeah, it should be file size greater than. I had less than. Oh yeah, because I copy pasted from there. All right, so get your units correct. We want greater than that size. And so now that should fit here. Cool deal. So there's my raw files. Those are 30 something meg. And these files here are 10 meg. All right, so that's cool. So that's showing that. And notice it did not show file 1 or the wsettings.dat or the desktop ini. Those are all less than 6 meg. All right, so that's picking that up there. All right, so that's pretty cool there. Now, what I next want to play with is the output, right? Because it's not showing any of the pertinent information that the students that I was training cared about. Okay, it doesn't show the last modified date. It doesn't show the size. It shows the name, but it's kind of like the whole path. You know, it might be worth having just a file name, right? So, and we need to do that. So we could potentially create an object out of this, but in the case here, the solution we came up with, so I'll stick true to what I was teaching in the class here. We sent it over, we took the output and sent it over to select object, and then modified it from there. So I'll do a pipe there, and since this is going to scroll off the screen, I'll just hit the carriage return right after the pipe, which is still, PowerShell will still see that as one line of code, and we'll send this over to select object. And then property, so we want PS computer name, because that's telling us where it's coming from. All right, so what computer? Because remember, these results might be coming from multiple computers. So property, we want PS computer name. Okay, so we definitely want that. And then the next property we want, remember in that data, there was, let's see here, there was, go back up to the get member. We had file size, okay, and we had last modified. Okay, so I want those two pieces of info. All right, so I want file size and last. You remember to spell. All right. So anyway, so those are the things that I want to start with. So let me just make sure that that works. All right, so it's kind of always, build in pieces, make sure it works. So let's take the size off of there, and I just want all the files. All right, so DC1, got some puny files, last modified. All right, so because it's in, um, I'm having it display 4 properties or less, PowerShell does a table out of that. If I go 5 properties or more, PowerShell will make a list out of it, unless I tell it otherwise by putting this stuff in a module, defining a view, things like that. All right, so that gets us started here. Now we can't see the files, so it's more properties to add on here. All right, so what we could do is we want to add those other things onto here. So since this is going to get um, a little more here, what I'm going to do is I'm just going to put each one of these on its own line, like so. Um, and then the next one here, let's see, let's see, what was the original output there? So we could do just throw name on there and call it a day, if we wanted to do that. So I could just, so hey, I want to see name. And then when we run it, we'll see the names there. All right. So uh, now, if you also wanted to rename it, let me show you. What if I don't want the property called name? What if I want it, called something else? So that's where, again, you could make your own calculated properties if you wanted to do that. So I could create a hash table. Inside of it, n equals, and then whatever I want to call my property. So maybe I'll do full path, and then semicolon, and then my expression, e equals, is a script block, and then I can call the object that's in the pipeline, and then dot name if I wanted to grab that. So I'm using the name property, but I'm making it a full path property. So I'm using the name property, making a full path property, because maybe that's what I want it to be called. So you could do something like that. So you're kind of defining what you want your property. So instead of a name up here, now it's full path, but it's the same data. So you could do that. And you could also use that same technique to get part of that data. Like I want just this. I want just the file names. So what we could do with that is we could do another calculated property. We'll do n equals, and we'll call this file name. We'll do something like that. And then the expression equals, and then here we're gonna grab $name again. All right, dollar underscore dot name. So dollar underscore is the automatic variable that represents the objects in the pipeline from the previous command. Okay, because remember we're taking getSimInstance here and piping it over to select object. So this represents every object coming from getSimInstance. And dollar underscore only works when you're inside a script block, by the way. Can't just use that anywhere. It has to be inside of a script block. And so property does take a script block here when you're doing the calculated property. So this part here, this outer part is the hash table, like ending there, beginning there. And then you got whatever the name of your property is, and then the expression, and then this inner part here. This is a hash table, so you're allowed to use dollar underscore there. All right. So now I can't just use name though. I need to kind of fix it a bit. I need to play with the data. So what I want to do is I want to lop off some of the stuff. All right. So what I want to do is I want to get rid of this. I want to get rid of everything up to the last backslash. So the way to do that, there's a couple ways to do that, but probably the easiest way that I found is if you know how to use regular expressions or regex, there's operators that can work with that. So if I use the replace operator, And what do I want to replace? I want to find any character, multiple of them, um, and then a backslash. So I have to do it twice though. You have to escape it. Because the backslash is a special character in regex. So if you mean to do a backslash, you got to do two of them. And that's what we're going to replace, and we're going to replace it with nothing. Okay, now normally how replace works is you have a comma, and then what do you want to replace it with? So if I want to replace it with just, I don't know, triple A, something like that, that would work. Okay, look really funny. Let's go ahead and run it. And yeah, notice the file name. So it replaced, okay, here is the full path, right? So it replaced this part here with literally the letters AAA. Okay, so what I want is I want to replace it with nothing. Okay, so you don't have to have that. So we'll just replace it with nothing. Right? So save that, and then now that should give us what we're looking for. So there you go. Now you might also wonder, well, Mike, what happened to the output here? Well, now I'm displaying 5 properties. So PowerShell made a list out of it, whereas before, here it's a table because it's 4 or less. Right? So unless you tell PowerShell what else to do, if it has to write 4 properties to the screen, it does a table, and if it has to write an object with 5 or more properties, it does a list. Right? That's PowerShell's default. Right? So that gets us going there. And now that pretty much sets everything up that we wanted to do in here. All right. So we have the parameters here. We're converting the date. Um, that actually I could have buried inside of this if right here. So that's probably a good place to put it. As a matter of fact, let's just be creative with this. So let me grab that. And then in $filter here, we'll go put that piece right there and close that off and tab that in. There we go. That makes a little more sense because there's no need to run to this if this parameter wasn't used, right? Same thing here. There's no need to do this if size MB wasn't called either. Okay, so that kind of makes a good place to put those. All right. Okay, so now, um, so the last thing that we wanted to do here is potentially allow for pipeline input. Right? So again, maybe that's not your thing, but it is something we could add in here if we wanted to. So for instance, like if I had a string in the pipeline, like DC1, which if you're not familiar what happens with that, put something in quotes and hit enter, PowerShell makes a string object out of it. So if you're not convinced, pipe it over to get member, and you could see that, hey, this was putting a string object into the pipeline. All right? So if I try to do that over to my script, file demo, it does not know what to do with it. Because remember, if you're not familiar with this, I have a video on pipeline parameter binding. Go check that out. But basically the gist of it is pipeline data has to be sent to a parameter on wherever you're piping it to next, whether it's a commandlet, a function, or a script. It needs to know where to go. And we haven't defined that in any of these parameters. Right? So if I ultimately want this data to go to computer name, so I need to tell it that. So what we're going to go and do is we're going to add in a parameter element. Okay, and then in the argument list for parameter, we'll add value from pipeline. All right, and provided you spelled it right, that should be perfectly fine. All right, so we can add that, and then now that should be able to pipe in. All right, so that's cool there. Okay, now it's not completely done though. So a lot of people do that and they're like, okay, I'm all set. But here's the problem. with where we're at right now. It worked, but if I sent multiple strings in, it's just going to do the last one in. And the reason for that is pipeline data is not like you're dumping a bucket into here. You know, take all the objects in the pipeline like it's in a bucket and just pour it into where it's going next. What happens instead is one object at a time is fed from the pipeline into whatever parameter you tell it to. Okay, so we need another loop. And that is a special loop that PowerShell uses called process. So when you're doing pipeline input, you establish three sections in your script: begin, process, and end. So literally the word begin, the word process, and the word end, E-N-D. Okay? Begin and end are both optional. You don't need them. Process you do. So what I'm going to do here is I'm going to literally type the word process and then an opening for a script block, and then all the code that you need to loop for every object in the pipeline, you put inside that script block. All right, so that's what's happening here. All right, so I'll just kind of tab all of this in, hopefully. There you go. So now we have that in place, and if I save this, both computer names should be recognized now. Okay, so there's localhost, and then there's DC1. So it did do both of them. All right. So that worked there. All right. Now let me clean up some white space here. So that's what process does. So the process block, because it is a script block, it loops for every time there's an object in the pipeline. Right? That's basically how it's going to function. Right? So if there's five objects in the pipeline, the process block will loop 5 times. Right? Now, I also mentioned a begin and an end section. So with those, you put the begin section over here. Helps if I know how to spell begin. You put the begin section there, and it's a script block. Okay, it could be one line or multiple lines. And then you put the end block, just like it says, at the end. And how those work is the code in the begin block gets processed before the pipeline input begins. Okay, so this runs before the pipeline is processed. In fact, if you do not pipe data in from the pipeline, the begin block never runs. Guys, that's a common mistake that people make, is they put code in there thinking, yeah, this is what I want to run once. Well, putting it in the begin block will only work if you're piping the data in. If I'm not piping the data in, like if I'm calling like this is not piping the data in, and the begin block will never run. So just be aware of that. And then the end block would be code you want to run once after all the pipeline data has been processed. So the end only executes once, whatever's in there. Same thing with begin. It only runs once. The process loops for however many times there's objects in the pipeline. Right? So that gets that going there. Now for me, I don't have code I want to run before the pipeline begins, so I don't need begin. And I don't have data I want to run after the pipeline's been processed, so I don't need end. So I'll get rid of that. All right. So that gets us support for pipeline based on what we need here. All right. Now, the last thing, if we wanted to add support in for piping in Active Directory objects. So for instance here, like let's say I did get AD computer and then identity DC1. Right? So that brings back an AD computer object. And let's say I want to pipe that over to my script. So file demo and not so much. Right? Basically because this object does not know where to go, okay? Because there's nothing in here that accepts that kind of object. So now you're thinking, well, what kind of object are you talking about, Mike? Well, if I pipe this over to get member, the get AD computer, we could see it's an AD computer object. Nothing in here that's accepting an AD computer object. This takes string, this takes integer, this takes integer. So, and in fact, this needs to take string. So I can't just change that around. So what I want to do, if I want to add support for this, is I need another parameter. All right. So the type of object would be this type of object right here. So I'm just going to grab that just to save on some typing. And so we're going to cast that object type into a parameter called dollar maybe AD computer, something like that. All right. And let's see. And we're going to want that to do value from pipeline. So let me grab this piece right here. Grab that. Did I hit insert by accident? Yeah, I think I did. Okay. So yeah, so let's put that there. And so now we have computer objects, AD computer objects coming in from the pipeline. All right. So now I need to put a little bit of logic down in here because everything in here is set up to start with something in computer name. So there's two things we're going to do. We're going to fix the parameter block here. So either computer name can be called or AD computer can be called, but not both. So we're going to make what are called parameter sets. And secondly, we're going to fix the process here. If AD computer is called, we're going to do something. All right. So we already have kind of some logic here, this kind of if thing here. So let me go grab the beginning of that because we're going to use that. So we'll do this for each computer coming in. Oh, come on. My copy didn't work. I hit the wrong hotkey. Hold on. Hold on a moment. So let's see. Where would be the place? I don't want it in. Yeah, I don't want it there. That was bad. We're gonna go put this inside a process, but before the first for each. So we'll throw it right there. Um, so what do we want to do? So if it contains AD computer, what do we want to do? Let's close off. So what do we want to do? So what we're going to want to do is take the object that's coming in from the pipeline and not feed it directly. We just want the name of the computer. All right, so we want the name property. All right, so that's the piece that I want. Right? Don't want all the rest. I don't want the rest of this junk. I want this as a string object, which if you look at name, it is a string object. Why is that important? Because you're going to take that value and eventually put it in here. And that's fed into here, and that's fed here, and this parameter takes string objects. All right, so we want that. So we're going to take whatever was called. So we're going to do dollar computer name equals dollar AD computer dot name. So we want to grab the name properties out of this, which was called if this was that parameter was used, right? Which if you're piping in those objects, that parameter is totally going to be used, right? Now the second part of this is we need to make sure that either this is called or this is called, but not both. All right. So what we do for this is we set up what are called parameter sets. So that's where you kind of group what parameters can be used together. So if you don't touch a parameter, it automatically belongs to all parameter sets. However, if you declare something here, so how am I going to do this? So in here, I'm going to add on the parameter element after value from pipeline, we're going to put in parameter set name equals, and then we're going to give it some name. Maybe I'll do AD for Active Directory. And then up here, we'll also parameter set name, and maybe we'll call that one PC. Okay, so they're in now different parameter sets that you have defined. Oh, and this one's kind of scrolling off here. So let me throw carriage return right there. So after a closing bracket, you can also do a carriage return, and PowerShell still sees this as one line. So we'll add that in. And then under commandlet binding, I need to throw another argument in there as well. Because the way it works right now, it might not work. So if we just take the script, file demo, computer name DC1, right, that works. And let's see, let's try piping in the AD computer. Okay, that works. Man. All right. Trying to think of a scenario. I know it won't work. I just can't remember the scenario off the top of my head. Let's just say if I don't feed it any, there we go. So if you don't feed it any parameters, like you'll get that weird error. Parameter set cannot be resolved. So what you might want to do is like, let's say if you had declared up here that computer name was mandatory, right? That means someone has to supply a value to it. So that, like it won't see that. So what we need to do is in commandlet binding, we have to establish a default parameter set name. And that's literally what you type in there. The default parameter set name equals, and in this case, PC is the default set that I want to use. All right, so do that. And then now if I run it without, see how it prompts for computer name. So it is reading this parameter as mandatory. All right, so cool. So that lets that happen. All right, so now that should cover all the different ways here. So let's do file demo, computer name DC1, and local host. And let's just do, just so I don't get a huge amount here, size 6 MB. So that grabbed everything, probably more than I wanted. Right, and it grabbed it from DC1 and from localhost. Right, let's maybe do greater than, how about 11? There we go. So there's DC1 and there's localhost. Okay, so that worked. So now, let's see, we wanted to pipe those in as strings. I've got that in a previous command here. So file demo, size 11. Okay, so that works as well. We already did the piping in of Active Directory computers, right? So that worked. And then last test, say you have that Active Directory computer as a variable, $AD. So I'm saving that computer object in a variable. If I take $AD, pipe it to get member, AD computer. Now, picture this. So we run our script, and instead of AD computer, we do AD computer $AD. And it works as well. All right. So that kind of covers the 4 different ways you can, so you can pipe an AD computer in, you can call it on a parameter, you can pipe strings in, you can pipe strings in, or you could call the strings directly on computer name. Okay, so that kind of covers our 4 different techniques here. All right, so let me zoom this down a little bit so we can see the whole completed script. Let's see. I don't want to get rid of my spaces there, so let's zoom this down a little more. All right. So there we go. So we can see that on one page like so. Come on. There we go. Oh, come on. There we go. So we can see the whole script there. Um, and I'll give it a shot. Sometimes YouTube is cool at this, sometimes it's not. I'll put a link to the completed script in an Azure storage account of mine that you could download the script from as well. So I'll do that after posting the video. So have a look there as well. YouTube might wipe out the link though, so if it's not there, I apologize. but I'll try to put a link there if it keeps it awesome. And if not, we've got the whole code here, and you guys were along for the journey as I was typing this out. All right. So so again, kind of the premise here, we were using get some instance. I could have set the script up using get child item. A lot of people had recommended that I saw in forums and stuff. Other folks had recommended Robocopy, believe it or not. Robocopy has a list function, -L, that you could use as well. So if anybody wants to see this set up that way, maybe drop something in the comments, let me know. The Robocopy one might be interesting because Robocopy outputs like string data. So it's not really PowerShell objects. So that would kind of be a challenge to make PowerShell objects out of that. And that might be the better approach if you have a lot of files that you wanted to sort through. Like if you had a server with a data drive that had like a million files on it. Supposedly Robocopy would be better performing than anything else. But this satisfied the requirement for the PowerShell class that I was teaching a couple weeks ago for the students that they asked for. So I figured I'd share it with you all as well here. So any questions, drop something in the comments. Let me know. If you like the content here, again, consider liking and subscribing. We'll have more episodes here as we build through different scripts. So I'm always looking for ideas of what might be a good admin topic to build a script around. So like I said, I stole this from from my students in the class I taught a couple weeks ago. So thank you for that, guys. You know who you are. Um, and uh, and yeah, thanks for watching and tune in for another Build a Script series episode. So appreciate everyone, and we'll catch you on the next video.